Okay, so we're going to be dealing with equations that represent electric current today. And so the first problem that we're going to look at is how many minutes will it take to plate out 40 grams of nickel to form a solution of nickel sulfate using a current of 3.450 amperes. And so we're going to look at the formula for electric current, which is I equals Q over T, which basically is saying that amperes equals coulombs, charge in coulombs, over time in seconds. And this is going to help us later in our equation when we're setting it up. And we're also going to utilize Faraday's constant in this case, which is 96,500 coulombs over 1 mole of electrons. And that's what that constant means. And so now what we're going to do is we're going to start off with our grams, and we're going to change that into moles. And we know how many electron moles take from that by the compound there. And then we're going to use Faraday's constant, and we're going to use our amperes and to get those. And then we're going to switch from seconds to minutes because the answer in the question, they want it in minutes. So that's what the 1 minute over 60 seconds is for. So a good way to check all this now is to cross out all your units before you plug it in, all the numbers into your calculator, to make sure you set up everything correctly. So our grams cancel out, our moles cancel out, our moles electrons cancel out, our coulombs canceled out, our seconds canceled out. So we were able to get the answer of 635.5 minutes when we plugged that into our calculator. And I used 4 different places because there was 4 significant figures in our amperes that was given. So that's how you do it that way. Now, let's look at the equation if we were trying to find amperes and we were given minutes and grams. So you're going to start off the same way using grams. You're going to continue to do all your conversion rates, although some of them are going to be slightly different now because they're over different things. You can still utilize the canceling out method to check and make sure they're right. So let's go over what we had set up here. We had 40 grams of nickel times 1 mole of nickel over 58.69 grams of nickel, which is our molar conversion rate. And then we did 1 mole of nickel underneath 2 moles of electrons, because that's how many moles of electron are transferred when it becomes aqueous. And then we used our Faraday's constant again, but switched this time so that we could cancel out our moles electron. And this is perfectly fine to do because it's a conversion factor. We're just simply saying that they equal each other. It doesn't matter which one goes over which. We just want it in a certain direction for it to cancel out. Now here's where it got a little tricky. Here you can see we left our coulombs without canceling that out, but that's what we needed because amperes is technically in coulombs over seconds. So that's why we then multiplied by our minutes and then multiplied by minutes over seconds so that we could get that seconds. And you can see that when we did that, we got the correct amount of amperes that was given in the problem earlier. Now let's try it when we are trying to find grams instead. So how much nickel in grams will plate out of the solution to form using that current and that amount of minutes. So we're going to start with minutes and we're going to change to seconds, then we're going to use our amperes, then we're going to use our Faraday's constant, our amount of moles in the nickel, and then we're going to use finally our molar conversion, which is the grams per mole of nickel. And you can see that when we plugged all that in, we got the same amount that was given earlier in the problem, and that all of our units canceled out properly to give us grams. So that's how you do electric current problems in 3 different ways.